car, mass 1200 kgs, travelling at 15 meters per second, collides head on with a truck, mass 5,600 kgs, travelling at 12 meters per second. After the collision, the vehicles remain stuck together. What's the problem? Entwined. Okay, that'll do. Entwined, I think, isn't it? How fast is the wreckage moving immediately after the collision? Yeah, so as the car and the truck hit each other, they're stuck together and then they move, they'll be still moving after the collision. And they might be just absolutely dead stops, but they could absolutely cancel each other out, but that would have to be exactly the case, which may, so if the answer comes out to be 0, then they've just completely cancelled each other out. Very unlikely. So probably looking at those numbers, given that the truck is like 4 or 5 times bigger than the car, but the car's only travelling a wee bit faster than the truck, I think the truck's going to win. So truck, car, when they hit, remain entwined, they're probably going to move in that direction. And the question is, how fast do they move in that direction? Okay? So we just do exactly the same as we did before. We work out the momentum before, total, and the momentum afterwards is the same. Okay, so I find it's actually usually quite helpful to draw a little picture. So we've got a car going that way. So this is the before. And we've got a truck excuse my drawing skills, that's not too bad, it almost looks like a truck. And a truck going that way. And we want to work out the momentums. Okay, so the momentum of the car, what's the momentum of the car going to be? 18,000. So where did that come from, Scott? Yep, so the 1,200 times the 15 for the car gives us 18,000. So the car's got a momentum of 18,000 kilogram metre per second. Yep. And the way I've drawn it, it's going that way. And the truck, because the collision said it was head on, so the truck's going straight the other way. And the momentum of the truck is, someone's going to work that out for me, 67,200. Yep. Okay, so the car's going this way at 18,000, and the truck's coming back this way at 67,000. So the question is, what is the total momentum before the collision? I'll write that in the middle. So before the collision, what's the total momentum? 49,200. And where did that number come from, Liam? 67,200. That one? Minus that one, okay? Because the same as we had before, they're going opposite directions, so they're going to partly cancel each other out, and we end up with that. And the direction for that is this way, okay? Because the truck was bigger than the car, so when you add them up, the truck's going to win, basically. Yeah? So before the collision, you've got that going on. Okay. After the collision, you've now got a truck-car combination. So yep, so you've got this trucky car thing, which is wedged together in a big pile of muck. It's all stuck together as a big collision thing. What's the momentum of that total thing? What's the total momentum of this thing? No. It's the same. It's the same, isn't it? So the momentum of this thing, so the momentum is still the same. Okay, so that's the key, is that the momentum before the collision is the same as the momentum after the collision. So momentum is conserved in the collision. Okay, so we know what the mass of this mess, so the mass of this thing is that one plus that one. Yep. So we know that the wreckage has a mass of 6,800 just by adding the two things together. We know what its momentum is, so we should be able to work out its velocity. A little bit of rearranging. So momentum is mass times velocity. Velocity is momentum divided by mass. 4,9,200 divided by 6,800 equals. Calculator, push some buttons for me. Come again? 7.33 meters per second. Yeah, so the truck was doing 12 meters per second, and it's been slowed down to 7.3 meters per second. And the car was going forward at 15 and is now going back at 7. So the car's had a change of speed of whatever that 22.3 if you add those two together. Because the car was going positive and now it's going negative. So it's had a whole change of thing.